Hi everyone, I'm Guru, co-founder and lead research scientist at Yertz AI with a background in computational neuroscience from Caltech. Welcome to the second soundbite of Modern Science Meets Indian Philosophy. Today I'm going to discuss the topic of the power of our thoughts and its potential to transform our future selves, drawing parallels from both these domains. We are taught from our childhood to be extremely careful with our actions and words as they are visible to the public eye, but a similar emphasis isn't typically enforced on the quality of our thoughts. A possible reason is because they're extremely private, so we tend to believe that they are innocuous and that their effects would remain concealed. However, our ancient Vedic texts do not subscribe to that idea. Instead, they emphasize the necessity to continuously train our mind in order to absorb ourselves in the right kind of thoughts, as it really holds the key to shaping our future actions, words, and ultimately our character. One of the quintessential texts on yoga, the Bhagavad Gita, composed about 5,000 years ago, speaks about this very thing, wherein Krishna, who takes the role of a teacher, vehemently emphasizes the importance of controlling one's mind, and especially because it has a major role to play in who we become. Of the many instances across the Gita that talk about this particular topic, I'd like to share two specific verses from the Gita that convey this message. The first verse, I'll recite the first verse. Karmendriyani sanyamya ya aste manasa smaran indriyarthan vimudhatma mityacharasu uchyate. Krishna here, in taking the role of a strict teacher, tells Arjuna, the student, that a person who performs sane actions to appease the public eye, but internally lets their thoughts feast on the good, bad, and ugly without any discrimination, can be considered a pretender or a cheater. Herein, he is urging us, the teacher is urging us, not to remain superficial by merely controlling our words, actions. Of course, that's better than nothing for sure. But in addition, to go deeper and actually control or mind our thoughts. The second verse I'll recite highlights the major reason why one shouldn't let their minds feast on anything and everything without discrimination. And here it is. Yam yam vapi smaran bhavam tyajatyante kalevaram tam tamevaiti kaunteya sada tad bhava bhavitah. Herein Krishna states that the thoughts one is absorbed in results in one gradually attaining to that state of being, basically implying that our thoughts carve out our future selves. So the next natural question for me is one who's trained in the modern scientific way of thinking is, can all this be validated to some capacity? That is, if our ancient texts like the Srimad Bhagavatam or the Bhagavad Gita, again composed close to 5,000 years ago, states that one's thoughts can lead to who we become, can this experimentally be observed to some extent? So, interesting enough, when I was reading a book called The Mind and Brain, written by Jeffrey Schwartz, who's an American psychiatrist and researcher, I came across a phenomenal experiment pursued by a researcher named Alvaro Pascual Leon. I Googled, and he's currently a faculty at Harvard Medical School, who in the late 90s worked on a beautiful experiment to infer the effect of our mental thoughts on our physical systems or on our physical body. I personally believe this paper and experiment hasn't received as much recognition as it deserves. So let me set some context before I dive deep into the paper. As we all know, our brain is an amazing biological system, and I'm sure you'll agree with me that to a good extent, it makes us who we are. Of course, I don't say we are our brains, but I will say brains play a sizable role in the personality we portray. So in the early 20th century, that's like early 1900s, much less was known of the brain, and around 1920, Wilder Penfield, a Canadian neurosurgeon, discovered something very significant about the brain while he was attempting to cure his patient who suffered from frequent epileptic seizures. So when he asked what that discovery was, he actually discovered that the entire body is mapped in our brain. And what does that mean? It basically means that there are different regions in our brain that receive information from different parts of our body. Namely, there's the visual cortex that receives information from our eyes, the auditory cortex receiving information from our ears about the sounds in the world. In addition, each and every part of our body, be it our fingers, legs, tongue, all of them have a mapping in the brain. So very quickly, for those who might be interested, how did he discover this mapping? So going back to early 20th century, the standard procedure then for localizing the region that caused epilepsy would actually involve opening the patient's skull, taking a microelectrode, right, and injecting small current into different regions of the brain and seeing if that invoked an episode of epilepsy. So while doing this procedure, he realized that as he was traversing the different regions of the brain, the patient felt a slight buzz in different parts of the body and sometimes an involuntary twitch. For instance, when he was passing a small current through the region of the brain that mapped to the thumb, the patient reported that they felt a twitch in the thumb, implying that there's a bidirectional connection from our brain to the body. So a natural question that might arise in all of our minds is the mapping of the body to the brain similar across all of us humans? If not, what affects this mapping? And there's a beautiful experiment that was performed in blind individuals who became expert braille readers that I think would help answer this specific question. So as braille relies heavily on tactile perception and the sensitivity of the fingers to distinguish between different raised dots that represent letters and words, they noticed that expert braille readers had a larger amount of their brain region dedicated to their fingers than the average human. Clearly showing that depending on the amount of use of our different senses or our different limbs, our brain either expands or shrinks that particular region, basically assigning different levels of neural estate to different parts of our body depending on how much we use them. So in this particular paper, the authors wanted to take this further and wanted to test a very interesting hypothesis. So before this study, it was very well known that actions we perform with our hands, our senses, has a clear impact on how the mapping in the brain changes. For instance, if a person loses a limb, then the part of the brain that basically encoded or got stimuli from that particular region of the limb basically doesn't get any stimuli. So it was well known by then that, hey, that particular region of the brain would be innervated by other parts. For instance, a person who loses their hand doesn't get any information, or that particular part of the brain doesn't get any information from the hand. So basically the region of the face sometimes might actually send information to that earlier region. So because you're not using that particular area anymore. So similarly, the question here was, how does the brain change, if at all, to mental thoughts of actions? So clearly it is known that by functioning, by moving your hands or by using a particular set of fingers, we know that the brain changes. The mapping keeps changing. But how does it change, if at all, to mental thoughts? If I'm thinking about moving my hand, what happens to the brain? What changes happen? So the authors, they designed a very beautiful experiment where they had 3 groups of individuals, and each group had roughly around 10 individuals. So the 3 groups were given slightly different guidelines and tasks. And at the end of every day, their brains were mapped to see if the task they had performed had any impact on their brain's wiring. Please note that this experiment was in the late 90s, so they didn't need to open the subject's skull to map the brain. They used a technology called TMS, transcranial magnetic stimulation, to assess how much the brain changed over the duration of a set number of days. So the first group was tasked to learn a 5-fingered exercise using the right hand on the piano. So for this, the group was provided a piano in the lab environment and was made to practice on that piano that same exercise for 2 hours every day for 5 days. And they were also instructed to not go back home and practice that particular exercise. The second group was also tasked to do the same exercise, that to learn the same 5-fingered exercise on the piano, but the main difference was that they were only made to see the piano and only imagine playing the piano without moving their fingers. So purely relying on imagination of the task without any actual action. So that means these volunteers would sit there, hands folded or probably hands behind, and just see the piano and imagine that they are playing this particular fingered exercise, and would also try to imagine what sounds those different keys, when they press it, would actually produce. Again, they were also made to practice that mental activity for 2 hours every day for 5 consecutive days. For the skeptics in the room, what I'll also add another point, that the experiment was very thoughtfully done, where they actually attached EMG sensors, basically trying to measure if the volunteer or the subjects who were in this group whether their fingers twitched or not, because they made sure that their fingers also don't twitch. That means they're only focusing on mental thought or mental action. They're only thinking about that particular action. And the third group was a control group. That is, they were given no instruction. Basically, they were told, hey, you're free to do whatever you wanted to do. But at the end of every day, all subjects across all these groups, they had their brains mapped. Specifically, the region in the left hemisphere. I'm getting a little technical here, but the whole idea is they wanted to see if the mapping of the brain changed corresponding to their right fingers. So, the group one were playing with their right fingers. So it was expected that if you play with the right fingers a bunch, you would actually expand certain regions in the brain corresponding to the right fingers. So they wanted to map and see across all these different individuals if their brains were being differently wired after this particular exercise. And so here are the results. The third group, it basically did no specific targeted exercise. They came to the lab environment, just hung out for 2 hours, did whatever they wanted to do. And they noticed, as they expected, there was no changes, no profound changes in their brain wiring corresponding to the fingers in the right hand. And this is very much expected. The first group that continuously practiced the piano physically 2 hours every day, they saw a gradual increase in the neural estate mapping to the fingers and extensors in the right hand. That just implies that, hey, if you play the piano continuously every day for 2 hours, you start noticing that the region of the brain that is basically connected to that particular finger or getting input from that fingers basically expands over time. And this happened over the duration of 5 days. And the most surprising result of all was that just the mere thought of thinking of the activity of playing the piano, that particular specific 5-fingered exercise, consistently also resulted in an increase in the neural estate, mapping to the fingers and extensors. So to summarize, the group that didn't do anything, there was no impact. The brain wiring remained almost constant, especially corresponding to those particular fingers. But both the groups, the group that was physically playing the piano and the other that was actually thinking about playing the piano, both had a significant change in their brain wiring. Another cool thing that the authors evaluated was, hey, were the folks who were mentally trained, right, when they were mentally practicing, did they also have a similar performance? So at the end of 5 days, they wanted to see if they actually could play the piano, or were they just like, or maybe the brain regions expanded and they could actually not perform the task at all. What they reported was pure mental training also helped with performance, but of course it wasn't as good as the group that had physically practiced the piano. But very clearly it was mentioned that the mentally trained group weren't far behind, clearly saying that visualization, thinking about the process deeply, even though you might not be playing tennis, but even if you're thinking about like moving your hand in a particular manner, doing some sort of thinking about shadow practice, for instance, all of that's going to kind of prime you for playing the game better. And I think with this, I was very fascinated because it just said that our thoughts and the way we direct our thoughts, the repeated thought process definitely helps carve our brain in a particular manner. And not only that, it then afterwards also makes us more able to do a particular task better. So with this, I'd like to finally summarize. So one thing is, mind your thoughts. They definitely are not as innocuous as we think they might be. There's a lot of power in our thoughts. The second is, if you harbor a particular pattern of thoughts repeatedly, if they are positive, your future self is going to be very thankful. But if not, that might not be most ideal. And third, especially when one feels trapped in negative mental narratives, please try to break free, seek help, reach out, pray. We always have the power to change our mental frameworks and physical body subsequently. Earlier, actually as late as the 80s, it was an accepted fact in the scientific community that the birth of new neurons and neurogenesis, or extensive neuroplasticity, happens only during childhood. But now we know that isn't the case. It even happens at the age of 80. Neurogenesis can occur even at that point. So to a good extent, the key for how we want to direct our growth is in our hands. I of course say good extent because, as all our yoga texts suggest, for the successful completion of any action, in addition to our endeavor, divine grace is absolutely essential. Finally, I'd like to acknowledge and share in the description all the resources that were used for preparing the content for the soundbite. In addition to sharing the links of the paper that were referred to in the soundbite, I'll also share a link to the Yurts assistant that y'all can interact with, especially if you had more questions in the research paper that I've done a deep dive on. Finally, let me remind you, there's a lot of power in your comments. Please leave me a comment if you're looking for something specific Or, of course, if you'd like to praise or critique something. If I'm equipped to, I shall research and share the same with y'all. If not, I'll invite scholars, guest speakers to address the same. Thanks so much for your time and attention, and I look forward to seeing you here very soon.